Hi, my name is Rachel. Welcome to our journey into Ethereum. Today we'll explore the Ethereum Virtual Machine, or EVM. It's the engine that powers smart contracts and decentralized apps. By the end, you'll see how it works, how it stores data, and why it's so important for blockchain systems. What is the EVM? The EVM is like a world computer running on thousands of Ethereum nodes. It's not physical, it's a virtual machine. Its main job is to execute smart contracts securely and predictably. Whatever rules are coded, the EVM enforces them exactly the same everywhere. This gives Ethereum both trust and true decentralization. The EVM as a sandbox. Think of the EVM as a sandbox where programs run safely and cannot escape. Contracts inside can't damage the outside world or other users. This isolation keeps transactions consistent across all nodes. It also means one person's contract can't interfere with another. That's why blockchain networks remain reliable and fair. Stack, memory, and storage. The EVM works with three areas: stack, memory, and storage. The stack is for quick calculations and temporary values. Memory is short-term scratch space that clears after each transaction. Storage is permanent and recorded on the blockchain forever. Storage is costly, while stack and memory are cheaper and faster to use. Why separate them? Different types of data need different handling. Temporary numbers or results go in stack or memory, saving space and gas fees. Permanent records like balances, votes, or ownership must stay in storage. This design improves efficiency and speed. It also ensures users only pay for what they truly need to keep. Opcodes and gas. The EVM runs on opcodes, tiny instructions like add, store, or send. Each opcode consumes gas, which is like fuel for computation. Gas prevents people from running infinite loops or overloading the system. Every operation has a fixed gas cost. Developers must write efficient code to avoid wasting gas and money. Gas example. Adding two numbers costs very little gas, but writing data to storage costs much more. That's because all Ethereum nodes worldwide must update their records. Gas ensures heavy operations are used carefully. Without gas, the network could be spammed, slowed, or even crash. State Trie Ethereum tracks all data in a state trie, a special tree-like structure. It stores balances, contract code, and storage for every account. Each transaction changes this trie in a verifiable way. This makes data checks faster and more reliable. Nodes don't need to reprocess everything from scratch each time. Storage trie. Each contract has its own storage trie inside the main state trie. It keeps contract-specific data like votes, token balances, or configuration values. This structure allows quick lookups of stored information. Even with millions of users, it stays efficient. It's one of the reasons Ethereum scales better than it seems. Accounts in Ethereum has two types of accounts. Externally owned accounts, EOAs, are controlled by private keys like regular user wallets. Contract accounts are controlled only by code. EOAs can send transactions on their own. Contracts only act when triggered by a transaction or another contract call. EOAs versus contracts. EOAs belong to people, while contracts follow programmed rules. For example, Alice's EOA can send ETH to Bob's address. If Bob has a contract account, Alice triggers its logic instead. That contract might release tokens, update a record, or enforce rules. This difference is what powers decentralized applications. Calls in the EVM contracts communicate through different calls. A normal call simply invokes another contract. Delegate call runs another contract's code but uses your own storage. Static call runs code in read-only mode, meaning no permanent changes. These call types provide flexibility, safety, and control for developers. Example of calls. Imagine a voting contract using a math library for calculations. With delegate call, the library code runs, but saves results in the voting contract's storage. A normal call would save them in the library's storage instead. Choosing the right call type avoids costly mistakes. It's one of the trickiest parts of contract design. Contract creation contracts are deployed using Create or Create2. Create simply deploys a new contract at a fresh address. Create2 allows predictable deployment. You can calculate the address in advance. This predictability is especially useful for wallets, upgradable apps, or factory contracts. Create2 example. Suppose you want a wallet that always appears at the same address for a user. With Create2, you can pre-compute and share that wallet address. Later, when deployed, it will match exactly. This improves reliability and builds user trust. Many decentralized finance apps use this trick. Logs and events. Smart contracts often need to speak to the outside world. They do this with logs and events. Logs are pieces of transaction data stored on-chain. Events are developer-friendly versions of logs that external apps can easily read. Wallets, explorers, and dashboards all rely heavily on them. Bloom filters. Searching through millions of logs could be slow, so Ethereum uses Bloom filters. These filters quickly check if a log might contain your search term. They aren't exact, but they are extremely fast. This makes finding events practical and efficient. Tools like Etherscan and MetaMask use them behind the scenes. Bytecode and disassembly. Contracts are stored as bytecode, the raw instructions the EVM understands. Developers usually write contracts in Solidity, but the blockchain only runs bytecode. Disassembly tools can translate bytecode back into human-readable steps. This helps in debugging, auditing, and security checks. Understanding it gives deeper insight into contract behavior. Precompiled contracts. The EVM also provides precompiled contracts, which act like built-in shortcuts. They handle common heavy tasks, especially cryptography, much faster than normal contracts. Instead of writing complex code, developers just call these precompiled ones. This saves gas, improves performance, and makes Ethereum more efficient overall. EVM compatibility. The EVM has become the global standard for smart contracts. Chains like Polygon, Avalanche, and Binance Smart Chain all support it. This means Ethereum contracts can often run on these networks with almost no change. Compatibility has fueled massive growth in the blockchain ecosystem. Slide 21, Recap and Closing. We explored the EVM's core features: its architecture, gas system, state trie, accounts, calls, contract creation, logs, bytecode, precompiled contracts, and chain compatibility. Together, they make Ethereum secure, predictable, and widely adopted. The EVM is truly the beating heart of Ethereum and beyond. Thanks for joining this deep dive. EVM compatibility.